start.
Okay. Okay. Good afternoon to all. Welcome to the last webinar of IE-Structi for this year. Today, we are going to have a webinar on the topic of cantilever erection of steel bridges. It is a topic of great interest to bridge engineers in general, particular, and in general to all civil and structural engineers. And I have with me two stalwarts of the industry, Professor Achyut Ghosh, an expert on the subject, and Professor Mahesh Tandon, who is going to moderate this session. Without further ado, let me have the privilege to introduce Professor Mahesh Tandon, and then I will hand over the floor to Professor Tandon to introduce our speaker of the day, Professor Achyut Ghosh. So Tandon Sahab is well known to all. There is hardly any need to introduce him, but still, for the sake of records, he is the past president of Indian Association of Structural Engineers and managing director of Tandon Consultants Private Limited, and he is a guest professor of IIT Gandhinagar. He is an international expert in the field of structural engineering. There are many structures designed by Professor Tandon which has been very widely acclaimed and have received recognition not only in India but also internationally. He is an honorary fellow of Indian Concrete Institute, is president of Indian Society of Wind Engineering, immediate past president of Indian Association of Structural Engineers, member of National Committee of Civil Engineering, Institution of Engineers India, and under the AICT INAE program, he was appointed distinguished visiting professor at IIT Kanpur, IIT Roorkee, and Gandhinagar. He has accreditation of International Professional Engineer India. Now I would like to hand over this floor to Professor Mahesh Tandon to take it forward. Tandon sir.
Thank you, Mr. Alok Bhaumik. What a pleasure it is to introduce my old friend, perhaps of the last 50 years, Professor Achyut Ghosh. In the old days, Professor Achyut Ghosh was synonymous with bearings and expansion joints. You could not speak two sentences without mentioning Professor Achyut Ghosh when you were discussing bridge bearings and expansion joints. And of course, his expertise didn't end there itself, as you would see from the brief CV that I am going to read to you. Well, more for people who are younger and may not know Achyut that well. Professor Achyut Ghosh, born 1941, first class first in BE Mechanical from BE College, Shibpur, fellow of the Institution of Engineers India, presently in YT of the Technical Advisory Group, National Council Regional Transport Corporation, that is NCRTC, New Delhi. These are the people who are making rapid rail, and the first section that they are working on is from Delhi to Meerut. He is a member of the several IRC committees like B5, B6. I forget what they were. Achyut, would you tell us what was B5 and what is B6?
Anyway, B5 is steel structures and steel bridges, and B6 is bearings and expansion joints.
Okay, thank you, thank you. So B5, like Achyut mentioned, it is steel structures and steel bridges, and B6 is bearings, bridge bearings, that means.
Yes.
And he's been there from 1967 in these committees. He's also a professor and member of Board of Studies in the Department of Construction Engineering, Jadavpur University. And he's been there from 1996. He was awarded contribution to engineering fraternity in 2011 from the West Bengal State Center of the Institution of Engineers, India. Achyut specializes in equipment design like bridge bearings, expansion joints, shock transmission units and dampers for bridges, piling equipment, various equipment for steel plants like molding machines, defense factories like transfer car, electro slag refining, etc. Railway traversers, cranes for bridge erection, this was connected with the Vidyasagar Setu. And of course, he's also a specialist in what he's going to speak today, that is cantilever erection of steel bridges, biaxial testing machines for testing of seismic equipment, etc. So we have all seen and heard, and we know about cantilever construction of concrete bearings, but not many people know about the same technology or similar technology being used for steel bridges. So that is the subject of presentation of Professor Achyut Ghosh today. So may I request with these few words to Professor Ghosh to take over and give us an idea of the cantilever construction of steel bridges. Thank you.
Thank you, Professor Tandon. Professor Tandon, I am calling Professor Tandon, but he's my friend, great friend for a long time. And Alok is also my friend. Somehow Alok is a little bit junior to me, but Professor Tandon, I believe, is almost my batchmate. I am 61 pass out. Anyway, I must thank ISTAT for kindly permitting me to take their forum and do these presentations, and thank Professor Mahesh Tandon, who spoke out of love for his friend, who spoke happily about me, which maybe I don't deserve all this, but anyway. And Alok is my very young friend for a long, long time. Anyway, so today, honestly, Alok, I have got something I have kept up my sleeve. That is, I'll be talking about cantilever erection of steel bridges, but I'll stress on preferred numbers, which is surreptitiously introduced in this, which I hope once I go through, you will kindly appreciate. So I'll share my screen. Okay. How do I do it? Yes. Share. Yes. It's okay. Yes.
Achyut is very competent in all these digital things.
At the age of 81.
The way you started, I thought you are handicapped digital like me. But
अरे भाई हम सीख लिया थोड़ा 15 minutes पहले उनके पास हम सब सीख लिया कैसे कैसे करने होगा. Honest. Okay. So okay, this I'll put like this. How do I do it? Okay, that is fine. So okay, we go next. So as I said, this is our subject today, but to our friends in the engineering profession who does not use the technology of preferred numbers in their profession, I believe they are losing something. So in the ploy of this cantilever erection steel bridges, if I start talking like preferred numbers, like a professional like talk, I think people will fly away. They will be afraid. So in between this cantilever erection scheme, I'll introduce the subject of preferred numbers. How do I select the length of the jeep? How do I select the length of the mast? And various other things. How do an engineer select the dimension of a room? How does an engineer select the span of a bridge? All this will come into our discussion. So I have a habit of a roof garden in my house in Salt Lake in Calcutta. So whatever you are seeing, the various vegetable items and all interspersed inside the slides, they are produce of my roof garden. So I'll show you now a few bridges which has been erected by the method of cantilever construction. This is a 5-kilometer long bridge, Naronarayan Setu at Jogi Gopa, erected by cantilever construction method. This is something beautiful, and it's a 5-kilometer long. I used to visit there every month for a period, I mean, not every month, maybe once in 2 months, once in 3 months. This was constructed by Jessup's, BBJ, and fabrications were done in Jessup's, Burn, Braithwaite, etc. This is my friend Gonsalves of GPT. I visited their site quite a few times at Ganga Bridge. When during construction, when the bridge is open, you just pass over in a car or in a train. You don't feel the enormity of the bridge. But when during construction, you have to use a bamboo ladder and go up and walk down this 2 kilometer, 3 kilometer, you feel what a construction thing, great construction is being done. Next. Okay. Operations will come, how the cantilever construction erection system, how they operate. What you do, the beauty of this scheme is you erect only one span. Maybe there are 28 spans, maybe there are 25 spans for 5 kilometer, for 3 kilometer, maybe 120 meter span, 103 meter span, double broad gauge, single broad gauge, whatever the combination. A bridge with a roadway on top, you erect this first span only, which is called anchor span. And this anchor span will progressively, the next one will be anchor span when this is erecting a cantilever span, which will come. So this is the erection of the trestle. This we do by a crane. Erection of the anchor span going on over the trestles, the first span. Erection of anchor span is going on. The same thing. Now the anchor span is almost complete. This is all on trestles and mostly on the shore area. So you get dry land. You can use your lorry on this roadway, Now, this is the anchor span completed in Patna Bridge. You'll find a green structure, a blue colored structure. This is not part of the final bridge, but this is necessary for erection purpose, for reducing the approach of this crane, for connectivity between the two spans, the anchor span and the cantilever span. The cantilever span must hang on to certain thing. So this this structure is necessary. We'll come to it. This you will see, this is in the Naranaran Setu over the river Brahmaputra in Assam and Jogi Gopa. So this is the anchor span. It is being created by on the trestles as it was you saw earlier. Now we have seen the operation of the anchor span. Now, before you use the crane, the crane must be tested. This is a photograph of a crane. This crane was designed by Jessups and manufactured by Jessups. This crane was being tested on ground at Jogi Kopa. This crane was designed by myself, and it is being tested in Patna. These are erections of various spans in Goa, in a estuary in Goa. This was done by Trafalgar House, Diden Trafalgar House. Again, we tested this thing on the ground. It was rough painted, but finally when it is used, it is being painted. This is the erection scheme, erection position. This is again, though we have tested in the ground, but up on the anchor span, this is a smaller span, approach span. So on the anchor span, we again test it. Testing, you cannot avoid. You will be testing once on the life of the people working. Depends on the testing. You are seeing the other side of Patna Bridge. Patna Bridge was started with two agencies, one on one side, another on the other side. But then the agency on the other side, they faltered. So in the middle span, from the middle span, another agency started doing this. This is the beauty of the cantilever construction method. Then you can start it. Once the pier is done, you can start it from anywhere. Now, we are talking about the tolerances. Anything in engineering you do, this is on my rooftop. Anyway, anything on engineering you do, anything, mechanical, civil, electrical, metallurgy, there has to be tolerances. The tolerances have to be specified. The moment you increase the degree of tolerance, the cost goes up. So when we are preparing a drawing, we keep it in mind where this item will be manufactured. What is the purpose of this job? Is it for the Sputnik? Is it for astronomical telescopes? Or it is a bridge, a simple steel bridge? The moment you can go on specifying stronger and stiffer tolerances, but mind you, the cost goes up. The cost may go up 10 times. So any engineer has to be very pragmatic and practical to specify the tolerances. He must know, the engineer who is designing, he must know in which factory this will be manufactured, in which workshop this will be manufactured. What is the competence of the construction team and site? He will put the tolerances accordingly. This may, to some of my listeners, by the way, I forgot to mention that Professor Premakrishna has been kindly listening to this. So I give my pranam to him. Sir, thank you for kindly listening. Anyway, coming back again, this tolerances, you can go on increasing, but I don't know whether this kind of discussions you have heard earlier, but please try to know who is the manufacturer, who is the constructor, what is the competence of that construction company, and fix your tolerance on that drawing to fit the contractor or the manufacturer. So here in fabrication tolerances, we are using Indian Railway Standard B1 specification fabrication erection of steel girder bridges, and then we are using Indian Railways SBC 2003 Steel Bridge Code, Indian Railway Standard Code of Practice for Design of Steel and Wrought Iron Bridge carrying rail, road and transport, Steel Bridge Code. So there are, for the railway bridges, they have copied, they have taken codes from the IS, but they have given the specification, this grade. There are 4-5 grades in IS, 3 grades specific. So they have said which grade to choose from. Now, pre-erection operations, what are to be done before starting of the erection. Let me introduce this is the hoisting rope, single rope. The purchase number of falls has been created here. This is called the bottom block, which is carrying the load. Kindly consider while using a crane that the weight of the bottom block, weight of the wire ropes, and weight of any tackle coming at the tip of the bottom block, all these will come. If the crane capacity is 16 ton, then this will be taken, it will be added to the weight of the material. If the material is 12 ton and the appurtenances for holding the material is 1 ton and the bottom block is 500 kg and the wire ropes are 200 kg, so all this will be added to the carrying capacity of the crane. So you select your crane like that. So this is the derricking rope. You have got the falls created here, and these are thicker wire ropes too, holding the jeep tip. And this is the mast. This is the tie, and this is A-frame. Then we have got the cantilage rear. Central, somewhere there is a central cantilage, and this is the rotating platform. This is carriage, undercarriage. Erection sequences. You can erect normally this crane, take erection crane, TEC. It may weigh anything between 30 ton to 110 ton. So you cannot erect a 110 ton on the ground and take the whole thing through. The cost of the crane will be too high. So what we do, we raise the elements. We do once trial erection on the ground, and then this undercarriage, central pin, rotating platform, cantilage, mast and tie, winches, jeep, cantilage rear, all this we lift by the crane. The crane may be a 12.5 ton crane with the required lift so that it can reach the top of the bridge, and it has the requisite throw. So your splicing of the equipment for this crane has to satisfy the requirement of the crane, or otherwise you have to, one has to ask the contractor that, look, my minimum weight of the undercarriage is about 33 ton. So your crane must be of suitable reach and required capacity at that reach. The crane from the ground will erect the machine here. The crane, they will erect here. So this is the lift. And of course, the weights are given in the drawing, weight of each individual element. You have to do that. So pre-erection operations, deflection of the erected span, which I will discuss gradually, effect of anchor span, buffer, link, temporary link. This I will discuss, and these are the related items: jacks, cantilage, traversing arrangement, additional bracket, pin pushing and extracting app. This I'll discuss. তোমরা আস্তে কথা বলো। So one thing I like to clarify, this erection crane has got very good stability in the forward direction. Again, not bad for the backward direction, but for the lateral direction beyond 30 degrees, its stability is not so good. So that is to be taken into account during planning, material transfer, etc. So here there will be limiting indicators. Then I'll show you anemometers, accidents, competent supervisors. Accidents do happen. In my country, the printing report of accident or writing article of accident is not done thing, but which is a great loss to the engineering fraternity. These are anemometers. No operation should be done beyond the service wind. When the speed of wind goes up beyond the service, which is in my country, it is about 20 meters per second. So these anemometers can be put over the office. It can be handheld. This is handheld, etc. But in a site where crane equipment is being used, this anemometer is absolutely necessary. Let us see. This is the anchor span. This is the erection span. Say this is not the erection span cannot stay as is without the connection. But considering that there is no connectivity, this anchor span will behave like this, and the erection span will behave like this. And these are the bearings. But since they are connected, without which the erection is not possible, the revised deflection will be along this line. For a 120 meter span, this deflection, when it is approaching the next pier, maybe 1.5 meter, 1.6 meter, 1.5 meter, 1.6 meter. So that correction is made in the link, which we'll discuss. So this is the link. These are the pins, 6 set of pins. These pins are 250 diameter, weighing about 500 kg to 700 kg. So we need special items to pull it. But it cannot be pulled when this is in the cantilever position. It must get a support on the next span, then it is jacked up, and then the pins are removed. This is not a part of the bridge, so this is used in the forward section. as I said, uh, when you are doing the compression, when you are doing this, there'll be a compression here, tension here. So this is the tension link, and this is the compression bearing block. It's a buffer block. It's called buffer block. I'll show you the drawing of this buffer block. This is the location. This is the location where the buffer block will come. This is one span. This is the next span. And my friend Gonsalves is there. So this is the buffer block. It's a little bit carved on this side, little bit carved on this side, and a 500 to 1 ton steel block, quite thick. The gap between the two spans is quite thick, so it is 250 millimeter thick and all that. So the drawing is there, and these are the verticals. Before you put the pin, you have to erect this. This is already erected, and this you erect. You have to put the pins. So these are the vertical supports. This is the link for 103 meter span. This is the link for 120 meter span. This is the vertical for 120 meter span. Now, see, we have got temporary bearings, we have got permanent bearings. Railway do not permit the whole erection to take place on the permanent bearings. You have to use the temporary bearings, and then after the erection is complete, one has to replace the temporary bearings by jacking up the span and use the permanent bearings. My theoretical friends who do not visit sites, they may be aghast looking at the condition of the bearing, what it looks like. But at site, things happen. Now, as I said, related items, jack, lifting at both ends, cantilage in the anchor span. I'll show you traversing arrangement for the lateral shift, additional at extreme cases, pin pushing and extracting appurtenances. Now, what happens? There are longitudinal line and there may be lateral shift at the tip of the erected span. So we have to correct it. This is the process of erection. Any span which is acting to which it is connected is called the anchor span. This is called the cantilever span. This is deflection crane. This is the, sometimes for a very large span, number of span, we use an additional crane, which is called follow-up crane, which we use for supply of the material. And then here, this anchor span must be loaded. The anchor span and the cantilever span at the end almost, they weigh the same. So, and with the deck erection crane on the cantilever span, this may fall down. So we use used rails. Here we bundle up used rails and we put another crane on top to give load to the anchor span. Now, this is the Orion make traversing jack. This is made in India. This lifts the end and shifts sidewise laterally. Sometimes the cantilever span may fall below the level. So you have to create a bracket to put the jack to lift it. These are the lifting and traversing jack. You lift it, then traverse it laterally to align along the long axis of the bridge. Sorry. See, the material has to be transported. It is really a dangerous thing to transport over the bridge. So we do the transportation on special trolleys. As you go on increasing the bridge, the next span, you have to go on erecting a temporary track on the same trackway, but this rails will be later on changed with new tracks. So, and these are not, in our country, this is human powered. People push it to take it from the end to the, or sometimes it is fed from the middle of the span by one more crane, which the material comes on boats on the river. Or there can be a roadway built alongside the bridge and the material may come with a lorry on the roadside. Now, national and international codes. Now, though it is national and international codes, but I have not given any international. There are ISO codes, but in my country or anywhere else, there is no such code for the deck erection crane. There are codes for 807 and 3177. These are design, structural and testing for cranes, and 3177 is the mechanical part of the cranes. We use this and we use various IPSS, interplant standards for cranes. You cannot give any crane, any size, any wheel. These are all standardized in my country. As a matter of fact, it is standardized all over the world. So this IPSS, these are still, all these steel plants in my country, they have come together and they have produced standards. They are called IPSS. So they are standards on crane, standards on bearing bracket, standards on the hook, standards on the pulley block, everything. So we use them. And I have used two more books, Material Handling Equipment by Rudenko, Russian publication, Material Handling Equipment by Alexandrov, Russian publication. Failures. As I said, beginning somewhere, that we don't write papers on failures. This is very unfortunate, since people are afraid that the blame will come to them, they will be jailed, their services will put to naught. But in foreign countries, the codes get changed due to the publication of the failures. The failures are the knowledge base. Failures are the knowledge base in my country. You see, this is a failure of the Vivekananda flyover. I was called by some of the newspaper people on the day of the failure. So I went there and these photographs are taken by me. So there is no question of any infringement. So this is a failure of a design. But unfortunately, no paper has been written on the failure of this Vivekananda flyover in my city, Calcutta. Had it been written, I can promise you, sir, there will be a lot of knowledge base gained by the engineering fraternity. Now, why the erection of Howrah Bridge is coming? A same type of crane has been used for the erection of Howrah Bridge. And that crane weighs 622 tons. This is the Howrah Bridge. And I'll show you what is anchor span, what is cantilever span, what is suspended span. This is the balanced cantilever end span. This is the balanced cantilever end span. This is the suspended span. Out of this is the counterweight anchor pier. These are anchor pier. This is the load bearing pier, and this is the forward cantilever span. So this is from other lecture on Howrah Bridge, but this has been put there just to tell you which one is which, the terminology. Now, how the cranes were erected, where they were assembled and all that, we cannot go in deep to it. I've got 2 slides only. These are called creeper cranes, one on each side, and they are tied together. The whole appurtenance with their leveling, this is the leveling system. As the slope changes, this leveling system changes. So all this taken together, it's 622 tons. This is on the anchor span being erected. This is on the cantilever span. On the cantilever span, this will be erected. This is done from the ground and rest. At the end, the creeper crane, they're calling it the creeper crane, at the end of the anchor span, and then other creeper crane, and the end of the creeper crane is used to erect the towers. This is a lovely plant. It's called Asplenium nidus. You go to Singapore, you will find a lot of these plants on various trees. But this propagation is rather difficult. We have to use a tissue culture lab to propagate it. This is on my roof. Now, as I said at the beginning of the lecture, that I'll be discussing about preferred numbers surreptitiously in the form of, in the cantilever erection of steel bridge. Had I called it a lecture on preferred numbers, there'll be hardly 100 participants. But I believe now the number is much more. Anyway, as I said, anyone of our engineering fraternity who is not using preferred numbers in his day-to-day work is not doing justice to the profession. Sir, let us see. This is a cantilever erection crane. This has got a jib. This has got a mast. Now, how do you select what the jib? Maybe 25 meter, maybe 31.5 meter. The mast may be 22 meter, 22.4 meter. The mast may be 28 meter. So how do you cannot transport a 28 meter item? So you have to splice it. Splice it. So what will be the splice length? How to decide? That is the contribution of preferred numbers in the whole world. The whole fraternity, engineering fraternity, and all other statisticians and everybody, they use preferred numbers. See, these elements, they are common. You make a jig in the factory to manufacture this so that they match each other. So they have to be common. So this profile is common to this also. So we settle the length of the splice from the concept of preferred numbers. The width and also the jib length and the width and the angle size, they have got relations. For certain kind of jib length, this may be 1 meter. For certain kind of jib length, this may be 900. For certain kind of jib length, this may be 800, etc. So how do you do this? How do I get this 5.56001, or let us call it 1 and 5.6? How do I get it? I get it from the preferred number series of R20. This is 1, this is 5.6, and these are 20. Why R20? These are 20 steps. So This, it could be R5, it could be R10, it could be R20, it could be R40. Once you go through this IS 1076, part 1, part 2, part 3, or ISO 3, you see, ISO has considered this so important that at the beginning of their series, at ISO 3, it is preferred numbers. So there are 3 parts: ISO 3, ISO 17, ISO 497, all published in 1973. And our 1076, part 1, part 2, part 3 has been published in 1986. We just copied it. We didn't do any change. We just copied it and said it is taken from so and so ISO. I'll come to the beauty of it. So you have seen R20 series. The next one is R5 series. R5 series. This is R prime 5. This is R5. What is the beauty of it? Say you want to produce a product, let us say electric motors. You want to produce electric motors 1 to 10 kilowatt. If you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can make inventory of 10 items. But say somebody wants 1.5 kilowatt. You offer him either 1 or 2. So there is a variation of 50%, 33%. In any stage, there will be a variation maximum of 18.5%. This is 5th root of 10. Why it is R-5, R5, 5th root of 10. These steps are 5th root of 10, and these are single decimal value. One Mr. Renner, a French army person, he has discovered it. And since then, it is extremely valuable tool given in the hand of all engineering fraternities. So we call it R10. We call R10. We use R prime 10, R10, R double prime 10. There are certain sacrifices, but these are the actual 10th root of 10. 10th root of 10. This is R20. This series is extremely favorite to me. In all my designs, I have never deviated in selecting the length of any element, the dimension of element, the whole size from this series. It can be multiplied by 10, multiplied by 100, multiplied by any power of 10, and so also it can be multiplied by 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, ad infinity. And this goes on giving you a series which is very compatible when you fit each other. When you fit, what is the size of your room in a building? We select from preferred numbers. What will be the size of a span? We select from preferred numbers. You see, in Delhi, so many flyovers are made during the 1977 Asian. I know Mr. Sitla Saran, he is dead. Great engineer. My regards. So Mr. Sitla Saran decided we will make one single span and then we can add on other spans. But that single span was from preferred numbers. Now we have got now R40. These are the R40th root of 10. They are the limit ends, the 40th root of 10. I have not heard of 80th root of 10. And these are the series R40, R prime 40. I don't use this very often. I use R prime R20 very often. Sometimes R prime 20. More or less, more time I use R prime 20 than R20. There is hardly one difference here. R prime 20, and rest are all. And there is another difference here. 3.15, 3.2, 3.55, 3.6. All these series you can multiply by 10, 100, and you see if you make a product, your product size will be reduced, your inventory will be reduced, and your fitting technology will be much improved. This has preferred numbers, the whole series, R5, R10, R20, R40, and this is the root. This is taken from the code, just a dead copy, all the series. And this is Renard number, and this is our preferred number. Various series. Say you are preparing electric motors. All the items all over the world follows preferred numbers. See the height of this center line of the shaft, the diameter of the shaft, so that anybody, you call it frame size, anybody can select any frame size for the kilowatt produced, but it matches all over the world. That is the beauty. Your fasteners, everything, your fastener threads, everything follows preferred numbers. Otherwise, the world will go mad for spares. You import one item from Europe, one bolt gets lost, you replace it with another bolt. Unless there is preferred numbers, it will be a mess, whole lot of mess. You see our steel production, the rods, the bright bars, the plate thicknesses. Plate thickness, I can tell from my memory, 10, 12, 16, 20, 25, 28, 32, 36, 40, 45, 50, 56, 63, 71, 88, 90, 100, etc. So our steel plants, and if you look at our standards, IS 6, you'll find all our structurals, they follow preferred numbers. So I was thinking of asking you to stop recording, but doesn't matter, forget it. So I'll show you now design and drawings. Now we are almost at the end of our, I have got another 3-4 minutes. Some 10 minutes has been lost. I have got about 13 minutes. Okay. So this is the crane. How do you go about design? First, you make a layout of the proposed bridge. What will be the support possible? And what will be your individual node size, the diagonals, the weight of the bottom chord, the weight of the top chord, and what will be the reach of the crane. So you need the worst weight, the bottom chord, the bottom chord, the bottom chord, and the reach corresponding, or the worst reach, if it is standing here, this diagonal or this vertical, the worst reach and corresponding weight. These two are necessary for designing the crane. And there is one philosophy in design of a crane, that is you fix up the member, top chord, bottom chord, and the diagonals for the crane weight that it carries, not for the self weight. It is a railway is designed for a simply supported span, But here, when you are erecting cantilever span, that becomes a cantilever to the anchor span. So the whole role is reversed. In the usage, the top chord is compression, the bottom chord is tension. During erection, the bottom chord is tension, the top chord is tension, the bottom chord is compression. So but we don't want to increase the material for erection stages. That will be a permanent loss. So what we do, we try to keep the weight minimum, including the safety features of as has been proposed in the Indian standard 3177 of stability, toppling, etc. So that is the whole idea why for each span, each design, the crane is to design separately to get the optimum usage, to use the minimum weight, so that we use the whatever material required for the passage of the train when it is being used as a bridge, but not for the erection condition. If we use more material for erection condition, that will be a total loss. Now, before we do the erection design, we do the analysis. We do the analysis of the forces in this 11 or 13 sheets. I'll show you. We make a sketch. We do the analysis. And there are 5-6 conditions of stability and safety on the front. The highest span of highest reach corresponding weight, the highest weight corresponding reach, zero weight, minimum radius. In all these conditions, you do various, you see different colors. So it is calculated under various load conditions. I do it for 5 times. Then there'll be a mechanical design, there'll be a structural design. So we make the summary of forces for the structural design. This will be transferred to the structural sheet. And this is the summary of forces for the mechanical design. This will be transferred to the mechanical sheet. Normally, I personally do not like total automation in our programs. This has been done in Excel. It has been done by me, of course. But we have done it separately. This is design mechanical. This is design mechanical. Then there'll be a design structural. So we take it, we don't continue. We take it and we put it in the mechanical sheet. This we take a mechanical sheet. This we take and put in the structural sheet. And then the structural progresses. I'll show you, as you see in the mechanical. So this is design mechanical. These forces have been taken here. Now, sometimes in my country, the forces are given in tons. But our calculations for bearings and other things, presently we do SI system. So this is done in newtons. So we get the forces in tons and kilograms, then we transfer them in newtons and then do the full design. The design of the lifting system, the design of the haulage system, the slewing, the derricking. This is derricking. This is derricking. These are the sheaves. As per IS and as per, by the way, the sheave root diameters are all as per preferred numbers. All as per preferred numbers. So these are the various sheave combinations, various falls. And this is the references used in the code. Now we are coming to design structure. Again, we manually transfer the forces here. We change it to SI, and then the design has been done for the G. There is a peculiar concept, or I'll say it's a lovely concept for in our standards. That is, this must, it must fail globally. It must not fail locally. So the failure, the L by R of this must be higher than the L by R of the mast or the jeep as a whole, so that it does not fail locally. It does not fail here locally. It fails globally. Then there is a computer part. Computer part means, you see, the rotary platform is rather longish and it weighs 22 tons. I mean, it varies depending on the size of the crane. And then there is a cantilage here, cantilage here. So if this gets shaped like this, then this your slewing function will be very much hampered. So these forces we put it in a computer, and we check the deflections at various points. There is a limitation of deflections given in Indian standards. We go by it. So these are the end results. Now we come to drawing. These are the genuine. This is part 2. These are the typical module of jib and mast. This is the undercarriage structure on which the whole thing rotates. This is the A-frame. We use a crane with the A-frame for lifting of the cantilage. These are the mechanical parts. Bottom block, a typical sheave. 2-3 sizes of sheaves used in a crane. Pivot pin, the central pin, which is against seismic forces. These are the slew wheels. Again, the diameters, all these diameters and everything, they follow preferred numbers. And there is IS on it. And I mean, there is no IS for slew wheels, but there is the IS for crane wheels, which everybody must follow. This is the LT wheel, long travel wheel. I am at the end of my presentation, and this is my roof where I live, where from I am speaking at the moment. This is the roof of BC252, and we have got various vegetables. It has been taken yesterday, this photograph. This is gourds, and these are tomatoes. These are French beans. This is your pepper. This is regular pepper, and this is bell pepper. And this is brinjal. This is brinjal, and inside this there are various other items. Whoever feels, I invite them. I am deeply involved in the horticultural society in this. We will die if we don't take care of our plants. So, and this, once you produce, say I produce, say 60% of my vegetable input on this small plot of land, and I distribute it to my friends, next door neighbors, etc. So I want to preach it that this amount of vegetable will not be transported. So that transport cost, that transport carbon dioxide is saved. So unless we are extremely careful, I am sorry, nature will not take care of us. The human race, Homo sapiens, as a whole, has got very low future. I cannot see very bright future for us. Anyway, that is another story. That is not a part of this. But since this is so dear to my heart, I have put it. And this is a garden which I produced in Ganganagar. Every single plant was planted by me, by my wife. But anyway, this is another story. We'll come to this some other time. So I thank the listeners for their patience. Alok and Mahesh.
Thank you, Siddha, for such an excellent presentation. I think you are a great storyteller, and I think this is an art which mostly the presenters should learn. So I hand over to moderator once again. Tandon Saab.
Okay. Thank you. Thank you, Professor Achyut Ghosh. It was a pleasure listening to you and learning many new things. I mean, the main thing was, if I can at least say from my point of view, the cranes and its design, that was something completely new that I had not thought of. We thought that we just look at the manufacturer's catalog and find out what is the radius at which it can operate and what loads it can lift. And we never really thought of how it is to be designed and all that, of which we got a fairly good idea from Professor Achyut Ghosh. And of course, it was interesting. There are many parts of the crane that one didn't know what it had. What they were called. They were just the long boom and the short boom, but there is more to it than that. So it was good to hear that. Also, I'm glad that he talked about the safety aspects, that the wind speed, when it goes beyond about 20 meters per second, I think the operations should stop. This is something which is a very valuable piece of information.
If you permit me, Professor Tandon, one crane which was in Hyderabad Army Jetty, one portal crane, it just, when the wind was blowing, it was not locked with the track. It just flew into the sea. It just went, the whole crane, weighing about 600, 700 tons. It just slid down over the track and went to the sea. It has happened.
Yes, I think that there have been many accidents due to this, or rather collapses of temporary structures, even for cantilever construction bridges. I mean, people leave it overnight. They don't tie everything down properly and all that, and next morning they come and there's no crane there. I mean, there's no disappeared. So it's but it's good to keep ourselves reminded that wind is perhaps one of the major problems. And talking about wind, my special welcome to Professor Prem Krishna, whose name is synonymous with wind, and also my special welcome to Mr. Amitabh Ghoshal, whose name is synonymous with steel. So both these stalwarts are here, and I hope that they have some penetrating questions from to ask Professor Ghosh. The other things that one came about was that deck erection crane, there is really no code And my suggestion is taking taking inspiration from this book, which is called Bridge Deck Erection, which has just come out, I think, a couple of years ago. It is, of course, mainly on concrete. But I think that Professor Achyut Ghosh, apart from spending his time on gardening, which which he's welcome to do, but while he's doing that, he must also spend time on perhaps writing a book on the deck erection cranes, as you call it, DEC, which is totally different from what has been given in the book that Achyut just flashed on the screen.
Mahesh, may I butt in here? Actually, long time back, Alok was talking to me on this subject. I told him, Alok, this is a I am afraid. I'm finding that today, after the demolition of Jessop's Braithwaite's and all, I am 81 years old, the only living person who is handling this crane, which is so sad. And so Alok said, what you are going to do about it? That started, I said, I'm going to write a book on it. So actually, this lecture is the preparation. I mean, I have given 18 pages to IS Structy as a write-up, but I am going to expand it to as many pages as like, giving drawings, giving designs, and giving whatever I tried to explain in this presentation, and put it logically with proper English. I promise, Mahesh, I am going to write a book on it.
No, I think that IAS Shakti would be very happy to publish it. Never mind the English.
It will be my pleasure if IAS Shakti takes the responsibility of printing it, publishing it. It will be my pleasure.
Yes.
It will be our privilege.
Yes, yes. So please write it, and then we'll see how to publish it, and it will be published by IAS Shakti. Don't worry.
Thank you.
The other important issue I think that Achyut mentioned was that there is really no knowledge base on failures, because nobody writes about failures. And that is a great pity, and I hope that things change over in the years to come. He talked about these preferred numbers. I have still not understood the theory completely, although I know it has got something to do with the number 10, and it's some kind of a fraction to the power, some fraction of 10. Other than that, I have not been able to follow. But he mentioned that this is how the secret of all mechanical equipment, at least, that so that there is, if you have, like he said, one bolt gone somewhere and you have to replace it, you don't have to start from the beginning. I mean, to develop a new bolt, I mean, you have to just say what bolt it is. It will have the same kind of threads, etc. I'm sure, and you can do that. So that was another good thing. I mean, people often wonder whether Professor Achyut Ghosh is a mechanical engineer, or is he a structural engineer, or is he a gardener, which we come to know. I think that he's a highly talented person, and it is such a pleasure to have a conversation with him on any subject. That is what I would like to say about Professor Achyut Ghosh. So that's what I have to say. But now we can go over to any questions that are either in the chat box or anybody wants to ask. And like I said, that especially Professor Prem Krishna and Professor and Mr. Amitabh Ghoshal, welcome any suggestions or questions by them.
I think there is a suggestion by Mr. Ghoshal for Professor Achyut Ghosh.
Really? Okay.
He's saying it will be useful for attendees to be explained the need for link shortening to negate the deflection at the tip of the cantilever, if that can be explained.
Yeah, I think that Achyut, if you can show that slide again, where you showed the hinged link and the buffer block at the bottom, which takes compression.
Yeah, this one.
This one.
30, yeah.
You see, normally, just a second.
थोड़ा इसको वो करो यार उसके
I-
presentation mode.
Yeah,
I mean after
okay.
you.
Okay, I'll do it. Okay, you see, obviously, due to the cantilever action, this is going to droop down. This is going to droop down for a 120 meter span. It has been measured that it went down by 1.6 meter. So how do you permit it to?
How do you prevent it, you mean?
I'll stay with my word permit. How do you permit it to sit on the pier? You can't. So that's why this link, this is going to fall like this. So if you shorten this, then you start with raised value, and from your today computer and everything, you know the deflection, including the weight of the deck erection crane. So that much of foreshortening, that much of shortening of this distance, after all, this bearing is a hinge. So if you do that much of shortening here, then ultimately the tip when you receive the tip on the pier, it will be proper. Or even then, you can use a jack and raise it, shift it. There are two kinds of leveling. One is vertical leveling, another is lateral leveling. Lateral, along this axis, lateral. So you do these two corrections with the jack and set it on the bearings. I hope I have been, it could be, have I been able to clear the thing?
Yeah.
Can
Achyuta,
Yes,
may
please.
I just
yeah,
compliment?
Kujalda.
Yes,
May I just
Amitabh, please.
compliment what Mr. Achyut Ghosh said? I
Sir.
think, Mr. Ghosh, you have a detailed drawing of the link. And
Yes,
perhaps if you flash that, you will see that on one side of that hole, of the link pin, there is a slotted hole.
Yes,
You
yes.
know, what is the purpose of the slot? That when you push this, the thing moves. Otherwise, you never be able to open the link also.
Of
That
course.
slotted hole is provided so that when you jack, the whole thing moves, and then you can take out the pin becomes loose and you can just hammer it and take it out.
Right.
Here you can see on the left-hand side, I think that slotted hole is shown.
Yes.
On one side, it is fixed diameter. On the other side, it is a slotted hole. The whole
Right.
purpose is that, and link shortening is done so that, as you explained, so that we can land on the top of the pier and not 1 meter below the pier.
Right.
You had shown a bracket. Bracket is a good idea, but then by the bracket, you cannot manage such
No.
large deflections. So
Bracket
the
is
thing
there.
to do is link sorting. And one of the key things which one should know when he is doing cantilever erection is this factor. That's why I mentioned. Thank you.
Sir, thank you, sir. You are a lord. You are the boss. You are the steel, face of steel in this country. Thank you, sir. Very
I'm
much.
tempted to visit your rooftop garden.
Sir, please come. And it is my pleasure that you and Professor Prem Krishna, amongst all others, you are present. That is my pleasure, sir.
I have visited your Ganganagar garden, but the rooftop I have not visited.
Okay, please come, sir. Please come.
Okay.
Okay.
Sorry for the interruption.
Okay, sir.
Okay, another question by Mr. Barun Kumar Basaka.
Basak.
Basak. What can be a rough idea of installation time as days or per meter? Days per meter. Okay, I think meters per day, perhaps.
Erection part.
Span of such cantilever steel bridges.
Sir, it is
Shall I
like
answer
that.
that question?
Please, 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 sir.
Mr. Barun Basak, the question of rate of erection is naturally dependent on many things. If it is a small span, say 150 feet span or 45 meter span, it can be erected in 7 days. But that does not mean a 300 feet span or 90 meter span can be erected in 14 days. It is not a sort of direct proportion. It depends on the complication, and as you have noticed, these spans which Mr. Achyut Ghosh has shown, they are double-deck bridges. You see, there is a rail deck and there is a road deck. So the number of pieces you have to erect is not directly again linked to the length of the span. So these things affect, but very generally, a very good director, and after number of spans, not the first span or the second span, when they are repeated span, say you have come to the third or fourth span, then a 45 meter span can be erected in 7 days. That is what BBJ used to achieve. A 90 meter span could be erected in about 15, 16 days. The time for a 120 meter span altogether is about 1 month. I mean, this is just an indication. I think your question meant that, though you said meter per meter number of days, but this is, I thought, would be the answer. Thank you.
Professor Tandon, I may add to it that, see, if this is one node, from one node to the next node, the erection crane is gradually progressed like this. So in a 120 meter span, if we can do a node in 6-7 days, a double-decker node, that will be called a fair time. One node in 6-7 days for a 120 meter double deck.
Very good. So, Mr. Basak has asked another question, which should have come earlier, I think, but anyway. What are the major broad stages or steps of actual erection of a cantilever steel bridge? I think perhaps you can show your slide again, which showed
Yes.
the stages of construction.
I think if he can look, he's sitting in America. Basak is sitting in America today, and he has risen up so early in the morning. It's glad for me. But anyway, he can look after the YouTube version of this lecture, and he will understand.
Oh, this is going to be put in the YouTube?
I think so.
Yes, sir.
Okay, so then I think it's better to see that. So, any more questions from anywhere? What is this? Can we have, somebody's asked a question. Let me just, thank you for, what are the major, no, I think it's not in the question box. There's something in the chat box, something about collaboration. Can we have something like cross UK for India, collaborative reporting for safer structures? They report failures, keeping the confidentiality on request. MP, Mr. Meera P. So I think if Mr. Meera P is here, and can we put him on the, allow him the audio so that we can understand a little more what he's talking about?
Okay.
Yes, Mr. Meera.
Sir, I am not
Mr.
Mr.
Meera, I beg your pardon. I beg your pardon.
No
Ms.
problem.
Meera.
See, there is an institute called Cross from UK. They report, we can report any failures to them. And there is a discussion going on and some measures suggested. So what the point came that we don't really learn from failures, and that is a fact. In India, failures are rather hush hush way. They are hidden up. And there is no really reporting, proper reporting about them. So can we initiate something like this, which will be extremely helpful?
May I answer this, Tandon Sam?
Yes, please. Alok.
Yeah, thanks. I thank Meera for raising a very good point. And let me tell you
Yeah.
that Indian Association of Structural Engineers are in touch with iStructy UK to extend cross to India.
Acha, acha, acha.
They already have done it in Australia
Acha.
and they have done it in Canada. The cross is a success in
Okay.
UK. And we are in discussion with the Institution of Structural Engineers UK
Yeah.
to extend that to India as well.
Yeah.
Thank you.
Because that will be an extremely useful thing for the engineers to learn lessons. Things can be documented, reported properly, and these can be used as an experience for future.
It will
Thank
be
you.
successful.
Very
It will
true.
be successful only
Yes.
if you are permitted to report.
Yes, people will start participating when it is open. An
But you
open
require
forum.
permission.
People will definitely start participating.
So,
because,
Goshalda, let me clarify here, because I have gone through in great detail.
yeah,
Cross will never tell the name of the project.
yeah,
Cross will never tell
yeah,
the people involved.
yes,
Okay.
And
Okay.
they will not even show any photograph to which can even by slightest of indication
yeah,
can tell
yes,
you about the project site and the project location.
yes.
So lot of editorial is required. Idea of this whole cross reporting
Yes.
is that they will tell you what was the problem and
Yes,
what
yes.
what are the
Exactly.
do's and don'ts for future projects
Yes, exactly.
without naming the project.
Yes.
And not only they don't name the project, they literally by in spirit, in letter and
Okay.
spirit,
Yeah,
they make
yeah.
sure that you
Yeah,
can't
yeah.
recognize the project.
See, what I feel that instead of giving freedom to the media and the reporters, it should be in the hands of engineers only who are dealing with it.
Madam, Professor Tandon,
Thank you so much.
can I? Yeah, thank you. Professor Tandon, can I add my line to it?
Sure, sir.
One line. That is, I must thank Meera
Yeah,
for kindly raising the subject.
yeah,
One.
yeah.
Second, about 6 months back, a team from National Geographic approached me. Can they talk to me about the failures of bridges in and around Calcutta?
Huh.
I said yes. This is to Professor Tandon. I
Yeah.
said yes. So what they did, they made an interview with a slide and with a video and all for the Vivekananda flyover only.
Huh.
They want to show it. I don't know, 1 year, 2 year, how or whether at all they will show it.
Yes.
And then later on, they will take Uttodanga or other Baliganj and like that. That was the situation as it stands now.
It will be a excellent initiative if Shakti can take it up. Thank you so much, sir. Thank you.
Thank you.
You are on mute, Tandon sir. You are on mute. Yeah.
Okay, thank you. So I think that we have come more or less to the end of the this particular session. And before I hand over to Mr. Alok Bhaumik for his closing remarks, if there is anything that anybody wants to say, as they say, this is your time, or you'll have to keep silent forever. You have the choice. If you have to say something, now's your chance. Okay, so since there is
Professor Tandon, somebody asked about the anemometer. These are very cheap equipment, 5,000, 10,000 rupees. I mean, less than 5,000 rupees and available in India. No problem. You can just buy across the counter and use it in any site.
I beg your pardon. There is one question which which Mr. Samir Malvankar has asked: push launching deck versus deck erection by crane. What is future and popular method?
Shall I answer, Tandon?
You have to answer.
Okay. Sir, the largest bridges in this country, including Howrah Bridge, the bridge in Assam, all this has been done by deck erection crane. And one in Assam, Dibrugarh, that has been, whole bridge has been gradually pushed. So that is, that tells about the efficiency of this crane rather than the other options.
I think Bogeybill Bridge is another one, if I remember correctly.
That is by push. Okay.
That is by push launching from both the banks, and it's quite a long bridge.
It is not deck erection. They have not used one second, sir. They have not used any deck erection crane. They have done erection inside the factory. There are two factories on the two sides, and they go on adding spans and go on pushing the whole thing hydraulically over PTFE stainless steel contacts over each pier.
May I compliment?
Right. Sure.
Right, sir. You see, I have learned my bridge erection based on cantilevering. The first, apart from Howrah Bridge, the next cantilever bridge was the Mokama Bridge, and my sort of hatekhori or nara, Badha was in that bridge. And after that, all my life I had gone on advocating cantilever erection. But Bogeybill gave me a time to rethink. You see, if you look at it, when you do cantilever erection, in most cases, because of the erection stresses, you have got to increase the permanent steelwork. In cantilever erection, the end bottom chord member, which is the weakest member because it does not take any load as such, very little load, you have got to strengthen it to take the maximum compression. And the top chord end member, which takes very little compression in service design, has to be designed for the maximum tension. So this adds to the permanent steelwork. And whereas when you are doing push launch, I mean, like Bogeybill type, it is not right to say push launching, it is pull as well as push. End launching, so to say, we have also been doing end launching. End launching also there is reversal of stress when the, sort of launching nose is cantilevering, and there are much less reversal of stress, and therefore the additional steel for giving temporary, for strengthening temporarily is not there. Earlier days when rivet was there, you could use temporary strengthening material, which used to be fixed by bolts, and then after the span has been erected, they used to be taken out by using drift and bolt and reused. So the permanent steelwork weight increase was not there. Now that today, after welding has come, that temporary strengthening is no more possible. At least it is not convenient. So therefore you have to permanently use, permanently increase the steelwork consumption. So that has made end launching a much more attractive proposition, and one needs to study this before deciding on the scheme. I know perhaps the Ganga Bridge, the Patna Ganga Bridge, where Stoop had been working as a consultant, I think of what the person in charge, Mr. Anirban Sengupta, I think he sort of made a comparison and found out that it is the end launching which will become comparatively economical. So this issue has now opened out. Earlier, it was only one solution.
No, I think that just to be fair, as far as push launching is concerned, there are not only these long bridges that we have been talking about, or what Achyut has been talking about. There are many bridges which we are making across the railway lines.
Yeah.
And in almost all those cases, we are using push launching. I mean,
if it is a single span, you have
exception.
no way. You have no anchor span, so you have to push launch.
So that you have to see as an engineer, you have to assess every situation.
Yes.
There are
yes.
no fixed
no ready-made solution.
methods that you should use in a particular situation.
Yeah.
You have to assess in that particular situation, in those local conditions, what is the best method.
Yeah.
And it depends on so many factors, and your ingenuity as an engineer comes into play when you select the correct method of launching. It should be safe, it should be fast, it should be economical. Of course, those are obvious reasons. Okay.
Professor Tandon,
Yes.
I have got something to say. One is in Panval, the over a 84-meter high pier, a 600-meter long pre-stressed concrete rail bridge was made by push launching 20-meter sections and pushing it. I was involved in developing this scheme. It was done with PTFE sliders over stainless steel on pier. This is one. We can discuss. That is a very interesting topic. We can have a lecture.
I think we can have a separate separate session on that, because there are so many push launching. Even of course, concrete bridges are also push launched, and one of them is in Delhi Metro over River Yamuna. But really, this push launching inspiration in concrete bridges has come from steel. They are the people who made it first. And then we thought, why not concrete?
Yes.
So that's how it is.
I have got another thing to submit. I will say the word, I will use the word submit. That is, in your lecture, summing up, you have raised the issue about what kind of person I am, whether I am a structural engineer or a mechanical engineer, and this kind of thing. I think this is something, whatever you practice, you learn. That's it. In our engineering thing, we are stamped with certain mechanical, structural, civil, and that kind of thing. But that is obviously no meaning. It is no meaning. It is your brain. After all, we use hardly 5% of our brain. So what choice you choose to take is your decision.
Yes, I think that what you said is right. That when you said we, you mean you. But
Mahesh, you are
one minute.
What stalwart? I am seeing stalwarts. Professor Amitabh Ghoshal, Alok, Mahesh. You are doing new things, new technologies.
What I'm saying is that there are some people like me where that 5% brain diminishes quite quickly and without telling you. There are no warnings. So if you have been able to retain that 5%, it's very good. Okay, I think that before people think that we are veering away from the subject of cantilever bridge construction in steel, let me just pass this on to Mr. Alok Bhaumik for his closing remarks, and then we can have an evening tea.
Thank you. Thank you, Tandon Saab. I think it was a great webinar once again, and I think Professor Achyut Ghosh was in his elements today. not only talking about the structure, about the crane,
Hmm.
but also about his garden, also about the, one thing is clear from his deliberation today, that, at the age of 80, he is hands-on. And he knows the nuts and bolts, and this is what is structural engineering all about. Though he is a mechanical engineer, but you see the kind of spreadsheet which he has shown, which is done by himself. And I know this typical style of Achyuta since 80s, because when I was a young engineer, I used to see the design calculations of Metco at that time. And all that formatting was done by Pochuda with R20 series. I still remember. And I think a brilliant engineer, whether he is qualified as mechanical, structural, doesn't matter. But a brilliant engineering mind, which is reflected in whatever he does. I thank him, and I look forward to more such presentations in future. And I also thank Professor Mahesh Tandon for moderating this particular webinar. Many thanks to Goshalda for his inputs and for his intervention in between. Excellent. I mean, all the way, it was a good webinar. And this being, as I mentioned earlier, last webinar of IS Shakti for 2021, I take this opportunity to say Happy New Year to all the participants and all the panelists. With that, let me close this session. Thank you.
Thank you.
Thank you.
Thank